Now periodic function. Next topic is periodic function related with the circular functions. Now definition for this. If on changing x to x plus L, L being the least, L being the least positive constant, the value of a function of x remains unaltered. Then the function is said to be periodic, and L is said to be the period of the function. Now once again we are having two terms here, periodic and period. Now if x is changed to x plus L, now what L can be? For example, we have gone through it that sin x, when we are adding 2 pi in it, one complete cycle, and sin x remains sin x, that is a periodic function. 2 pi is the period. Is it clear? So example, now sin x plus 2n pi is equal to sin x, cos x plus 2n pi is equal to cos x, cosecant x plus 2n pi is equal to cosecant x, and secant x plus 2n pi is equal to secant x. So here one complete cycle makes the term same. Okay, so for this 4 now, thus on changing x to x plus 2n pi, the above 4 t ratios remains unaltered. Now what the terms are here? Hence sin x cos x, secant x cosecant x are periodic, and their period is 2 pi. Now we are left with 2 more t ratios, that is tan and cot. Now another example we are having, now you can check it, tan x plus minus pi, sorry, let's write it, tan x is equal to, first of all, tan x plus minus pi is equal to tan x plus minus 2 pi is equal to, like this, it goes like this. Similarly, cot x is equal to cot x plus minus pi, cot x plus minus 2 pi, like this it goes on. Now here tan x and cot x are periodic. Tan x, here tan x and cot x are periodic, and their period is pi. Here their period is pi. Now why it is pi? Although we are having tan x plus 2 pi, okay, plus minus 2 pi, and here also cos x plus 2n pi, here also 2n pi, it is 2n pi, okay, so or 2 pi. So but the least among 2 pi and pi, which is the least? Pi is the least, okay. So above 4 functions have the period 2 pi and these two functions have the period